All right, so this activity is all about representing forces qualitatively, which means without numbers. You'll remember from your POGL that when we draw we show the forces on an object, we use arrows, vectors, just like in the velocity thing, and we use a free body force diagram. So the way you do a free body force diagram, you have two options here. Option 1 is to draw it as a circle. Option 2 is to draw it as a square. So you don't actually have to draw the object, you just draw a circle or square, and that serves as your object. Remember from the POGL that the object is the thing that feels the forces. So in this case, it's a ball. And then we're going to draw all the forces that it feels. So if you look at this ball, you know that it sits atop a table. The one force you know for sure it's feeling, since it's on Earth, is the gravitational force. And the way we represent that is with an arrow, FG for gravitational force. Then it also feels the table supporting it. We call that the normal force or support force. Either is fine. I like to use FN for normal. The word normal means 90 degrees. So when a force is 90 degrees to a surface like a table, then we call it the normal force. So if you were drawing it as a square, you could take it straight from the middle, gravitational and normal force. And the next phase in this activity is to fill out this table. Now this table will not use the last two because I only have two forces shown. So for the normal vector, the Fn, I labeled it Fn. The type of force is a normal force, or you could call it support force. Okay, so my battery's dying, and I'm going to have to do this really quickly. But the normal force, I write normal or support. The agent of that force, if you remember from the POGL, is, in this case, the table. It puts the force. The object feeling it is the ball. And the description would be the table supports the ball. So my other force vector is Fg for gravitational. That's called the gravitational force. Notice we do not call it gravity. It's not the same thing. The agent of that is the Earth. The Earth is the one doing that force. The ball feels that force. Just a hint, as you look across, your object will always be the same thing. It'll be the thing that you drew the forces on. In this case, the Earth pulls on the ball. So that's the first example. Second example, we have a hockey player gliding on frictionless ice. I'm actually going to let you try that one. I'm going to skip down to the basketball. So a basketball is in the midair of a free throw. The only force the basketball feels is gravitational force. There's no hand pushing on it when it's in the air. It doesn't feel air resistance because that's generally big flat things like wings on airplanes and pieces of paper. So that one is gravitational force. And then finally, we have some challenge questions. You don't really have to answer those right now. So give the basketball one a try. Try the hockey player. I want you to really think about the hockey player. Frictionless ice. So think about what forces, what agents are actually pushing on that hockey player. Remember, you can just draw the hockey player as a square. So you have the example up here, what you need to write. And you should be able to finish numbers 2 and 3. We'll go over these again and do some more examples in class tomorrow.